Now we move on to adding and subtracting with surds. And this is where most people start getting confused. Let's take a look at this example, 5 root 2 minus 3 root 2. Let's be clear first of all, this is not the same as multiplication. 5 root 2 times 3 root 2 was covered in the previous video, that type of question. Here you need to cast your mind back to two other areas of maths to understand properly what's going on. First of all, back to primary school for a moment. If you had 5 halves take away 3 halves, you've got a common denominator. So when you do the subtraction, the denominator stays the same. 5 halves take away 3 halves, the numerator is going to be 5 take away 3, which is 2. That obviously simplifies to 1, but I'm not actually that interested in the moment at that. I'm more interested in understanding that the denominator stays the same and the subtraction only happens to the numerators. In exactly the same way, 5x minus 3x, when you're simplifying algebra, you're collecting like terms. Well, we do have like terms here. 5x minus 3x just makes a very easy 2x. So in both of these cases, we have 5 somethings take away 3 somethings. 5 somethings take away 3 somethings. And the critical thing is, in both these cases, that the somethings, the denominators in this example, the letters in this example, they're the same as each other. Common denominators, like terms. It's exactly the same with surds. 5 root 2 minus 3 root 2. 5 somethings take away 3 somethings leaves us with 2 somethings, 2 root 2. And that is the key to understanding adding and subtracting. Surds. Now we're going to look at a couple of examples. 7 root 3 plus 4 root 3. Pause the video, try that for yourself just now. Okay, hopefully you recognise that this was very similar to my first example. 7 somethings plus 4 somethings, very similar to 7x plus 4x makes 11x. What we have here is 11 root 3. Finished, done. That's the easiest type of question like this that you can get. More likely you'll face something like this, root 63 minus root 45. Now all you can do here, other than the mistake that people often make, we'll come to that in a moment, is start splitting that 63 up into its factors, and the 45 likewise. What a lot of people do is they see this, they panic, they think 63 take away 45 is 18, and so they put root 18 for their answer. But what they're doing there is they're forgetting that it's not 63, and it's not 45. Root 63 is a completely different number to 63. Root 63, if you stop and think for a moment, is just slightly less than root 64, and we know that that's 8. Root 63 is just a little bit less than 8. Root 45, well, we know that root 36 is 6, and the root 49 is 7. This is somewhere in between 6 and 7. It's nothing to do with 63 take away 45. The answer cannot be root 18. So what we do, using the skills that we learned in the last video, we start breaking root 63 up and root 45 up using what we know about their factors. Now root 63. 63 is the same thing as 9/7. So I think I'm going to go to there. 45, well 9 5s are 45. So I'm going to go to there. Now, let's see what we've got. 3 root 7 minus 3 root 5. Now, if this was to be compared to a piece of algebra, something like, I don't know, 3x take away 3y, I've got to use different letters in my analogy because root 7 and root 5 are different surds. 3x take away 3y, that doesn't simplify because they're not like terms. Similarly, that doesn't simplify. So all we can do is leave that there. There's nothing else to be done to it. Let's look at one more example. Get you to try this one. Suppose we had 7 root 2 plus root 50. Pause the video there and give it a go. Okay, let's see what we've got. 7 root 2, I can't do much with that. It's the root 50 that I'm going to have to work with. 25 root 2. And so I've got 7 root 2 plus 5 root 2. And this now is very similar to this example up here. 7 root 2 plus 5 root 2 is going to be 12 root 2. And that's that finished.